Looks like a typical probability question. 30 students, 3 different things: squash, hockey, tennis. They can do different combinations of them. The thing that I noticed straight away here is you don't have any form of diagram or table. I'd say that's what the problem here is. There's no way we can solve this without organising that information. We could organise it into a Venn diagram. So we could do like, we could do that, squash, hockey, whatever the other one is, tennis. So we could fill that in, that'll help. I think that's probably going to be our best bet, to be honest. We could, now I can't think of any other way to do it. You can't do a two-way table. You can't say like for example, say you throw a dice and have a spinner. You could have the dice score there and the spinner there, or dice throw 1, dice throw 2 or something, and then you could create a table of what score you get if you get that dice and that spinner score. But for this particular problem with this information, I can't think of any way that we can think of it other than a Venn diagram. I think that would be the best way. And the fact that you've got a probability question but you haven't gone for some form of way of looking at it. So ways of looking at it is Venn diagram, tree diagram. It's not going to be any good in this case, is it? But you know, tree diagram is a possible way to display it. Venn diagram, tree diagram, two-way table, sometimes useful. I had something else in my head. Oh, and when you do discrete random variables, you know, the ones where you create the probability distribution. So this is x, this is the probability that x is x. You've got all the different possible things that could happen, and then you've got the probability of each one. Now obviously in this particular case none of them are going to be useful, but the general rule is probability questions need one of those. Otherwise, how can we even think about it? So that's what's gone wrong here. Not enough practice of turning information, deciding how to model the problem and put the information in. I think if you'd done that, it would be fine, because then it would be find the number of students who play all 3 would be the number in there. Given that the student, have you got the formula for given? No. So given that the student plays squash, find the probability that they do not play hockey. So what they've asked for here is the probability of, not squash. They've said what's the probability that they don't play hockey given that they play squash. Given they play squash, find the probability they do not play hockey. Yeah, what is the probability of not hockey given squash? And this is the probability of not hockey, I don't know how you spell hockey, and squash divided by the probability of squash. These words are starting to look stupid to me now. So the probability of squash on the bottom is this lot. That, add that, add that, add that. The probability of not hockey and squash, well, we'd have to look at where is not hockey, where is squash, where are both of them true. So not hockey is there. That's not hockey, not hockey, not hockey, not hockey. No, that's not squash. Not hockey, not hockey, not hockey, not hockey. Now, squash. Honestly, these words are starting to feel ridiculous to me. Where is squash? Squash, 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 squash. Okay, where is and? This bit had 2 ticks. This bit had 2 ticks. Nowhere else had 2 ticks. So the top is those 2 bits added up. And that's part B. 2 different students are picked at random, one after the other, without replacement. Okay, without replacement. So first of all, there's 30 in the class and we pick one. Now there's only 29 in the class and we pick another one. Given that the first student plays squash, given that the first person plays, so I'm feeling 2 things. Feeling tired. Feeling 3 things. But in terms of this question, I'm thinking, what they're asking me is, what is the probability that the second one does hockey, given that the first one does hockey? Now, the only reason I'm like, is that what they're asking? Is that they've already tested conditional probability in the question above. So they're going to test conditional probability twice. That's unusual. But what would happen if this was the question? What is the probability the second person plays hockey given the first person plays hockey? Well, this is the probability that the first person... Well, I'll write it the way around that it's written. What is the probability that the second person and the first person play hockey divided by the probability that the first person plays hockey? So that's one way I'm thinking about it. So then the question on the bottom, what's the chance that the first person plays hockey? Well, that's on our Venn diagram. That's everything in here. But they actually told us that it's 19 out of 30. So the probability... Well, no, wait, where's my notes down here? There they are. So the probability... Now, okay, I'm tired. I'm not sure how many hours I've been doing this now, but that thing we talked about with the timing and how you feel towards the end, even things that would have been all right 2 hours ago, I'm now trudging through like treacle. And this is why we have to work on the timing, because we don't want everything about those last few questions to be like treacle, which is why I suggested doing it differently with all the odd numbers first, then all the even numbers. But we'll talk when we have our session about timing. But you can see it in me now, the tiredness. Okay. Probability that the first person plays hockey is 19 out of 30. The probability that the first person and the second person play hockey. Okay, so person 1 playing hockey, the chance is 19 out of 30. Person 2 playing hockey, there's now only 29 people in the class and only 18 of them play hockey. So I think on the top we have this, and then on the bottom we have that, and then that will answer that question. I think that's what we need to do. The only thing that I feel comfortable with that now. The thing that threw me was them testing conditional probability twice. I thought that was unusual. So maybe there's a different way of thinking about this one, but that's my gut instinct about how we do it. Now, what's my gut instinct about where your marks are being lost? Because that's the more important thing for the moment. That's what we're talking about. I would say that you don't seem to know the formula for conditional probability because you didn't even write that down. Probability of A given B is probability of A and B over probability of B. And you've got two questions here that start with given. So I would say conditional probability formula, but also more importantly, looking at different probability questions and the way that you can represent those questions in diagrams or tables in order to allow you to answer the subsequent questions about that scenario. So basically, let's do a session on probability is basically what I'm saying.